Okay, so we're talking about this exponential growth model, and in the last video we actually wrote down the model, and now we're going to use it. So let's type this into the calculator. So my model is 0.32. Whoops. 1.055, and I want to know how long it takes me to get to $1, right? That's this question. According to the model, in what year will the cost of a gallon of gas reach $1? So that's a calc intersect question. So sorry, I should have explained that at the beginning, but this is following from the last video. We had talked about it a bit. So we want to look at find the intersection of these two curves. And I'm going to go to my window. Since my x values are in years, this might be okay actually, but we can double check by looking at the table and checking that to see when we get to $1. And you see here it's going to happen, I don't know, around year 25 or so, or 21 to 22. So actually my window was probably pretty good. Let's do zoom fit. I expect to see this kind of high up here, but hopefully we will get the intersection. Yep, there it is. Okay, so we're going to do intersect, first curve, second curve, and then let's move, move over to our guess. Hit enter again, and there's our intersection, 21.28. 21.28. So we're assuming that we're in the middle of the year, so 0.28 will not be enough to push us into the next year. So we just need to go 21 years from 1966. And so what would that be? That would be 87. Right. Okay. What is the doubling time of the cost of a gallon of gas? So doubling time, that's the amount of time it takes for the value to double. So we started off at 32 cents, so we basically want to know how long it takes to get to 64, which is essentially still a calc intersect question. And my previous window is probably still fine. So let's just go ahead and graph. And we'll do calc intersect again as soon as we get our picture. So there's our doubling time, 12.95 years. So every 12.95 years we double. Now I don't need to convert that to a year because the doubling time is a amount of time. It's not a calendar year question. And finally, part D, what is this model's prediction for the cost of gas in 2018? So that one's a note also that 2018 is an extrapolation, because 2018 is outside of the data set. So it's a bit risky to do this, and we'll know kind of roughly whether this was a good idea or not when we get our value. So we just calculate or evaluate the model, and I'm going to do it like this because I don't want to do any arithmetic. And there we go, 5.18. Okay, so if you remember 2 years ago, the cost of a gallon of gas was not $5.18, so it was quite a bit less than that. Um, so the model's prediction is not that great, but you know, gas prices are pretty volatile. So, all right, so that's some more work with a exponential growth function. Continuing with this model, same model that we just used. Let's think about changing this time unit. So if you notice, all three of these questions are about changing the increment of time that we're interested in. So rather than going yearly, what if we go every 10 years? By how much does the cost increase? Or what if we go every 3 months or every 12.95 years? Now you might remember 12.95, that was our doubling time. So, you know, you might know the answer to this one already. In fact, you should. But let's go back to part A. And all three of these questions, though, what are they actually asking you for? So when it says by how much does the cost increase every 10 years, we're looking for a rate. We're looking for a rate. Okay, so every 10 years, what am I going to do? Well, I just raise the factor to the 10th power. So I notice I don't even work with the initial value. That doesn't matter. All I care about is what is this raised to the 10th power. Okay, and then that's my 10-year, that is my 10-year, sorry, that is my 10-year growth factor, 1.708. Okay, now if I want the rate, the 10-year rate, I need to take this number, subtract 1 from it, and multiply it by 100. So that's basically going to be, the multiplying it by 100 is to get it in percent form. But so b to the 10 minus 1 is really what we're going to do. Now we want to use this full value. So don't use my rounded value. So there you go. So every 10 years, we have a 70% increase, 70.81% increase. Oops, probably not the best place to write that. Let me skip forward to our slide. Solution. And this is a summary of what we were just discussing. And let's just skip down to this last statement. The cost increases by 70.81% every 10 years. That is your 10-year growth rate. Okay. So going back to this question B, how much does the cost increase every 3 months? Well, this is the same kind of question, but the difference is that now our time unit is smaller rather than larger. So we're still going to begin with the annual factor, but what I'm going to raise it to now is not 3, but what is 3 of 3 months? What does that represent of a year? Well, that's 1/12 of a year. So I'm actually raising this to the 1/12 power. Hold on a second. Little mistake here that I want to clear up. The answer is correct. I just said 1/12. That's not right. It's 1/4. It's 3/12. So that's 0.25. Anyhow, our final answer is still correct. So we're raising this to the 0.25, and that is 1.013. I'm going to go ahead and subtract 1 from it and multiply by 100 to get my percent form. So that's 1.3, oops, sorry about that, 1.35%. And that's my 3-month rate, which is kind of weird, but that's what we found, the 3-month rate. So there you go. Okay, so back to part C. By how much does the cost increase every 12.95 years? So we know this is the doubling time, okay? So the shortcut to this is to, remember that and then note that our cost, and this is a little, we're round, 12.95 is a little bit of a round, is rounded a bit. So, that's why you see a little bit of difference here. So it's not just plain 2 because we did round this value, but so we approximately double every 12.95 years, and therefore our rate, what is our rate of growth? Well, we have 100%, 100.04% rate of growth every 12.95 years. So you might look at this and say, wait, I thought we were doubling. Why is that 100%? Well, if you have 100% growth, what that means is that you have 100% of what you started with plus another 100%. So that's 200 total, right? So your rate of growth is 100%. All right. Here we have another example. I think I don't have time to do this in this video, so we'll pick this up in the next lecture.